Good afternoon, class. So this will be the last recording for our application of derivatives. So this is a lecture that is supposed to be on Saturday, but because I lost my internet connection, so I just make it a recording instead. So these are composed of 4 problems, 2 for optimization problems, then 2 for related rates problems. So let's start with number 4. So the problem states that a building with a rectangular base is to be constructed on a lot in the form of a right triangle with legs 18 meter and 24 meters. If the building has one side along the hypotenuse of the triangle, find the dimensions of the base of the building for maximum floor area. So, medyo madaya lang tong problem, class, because the solution is already given, and as stated in the problem, we have a triangular lot. So we see a lot of this real estate na piece of land sa mga urban areas where landowners tend to maximize the use of the land because the land itself is very expensive. So in this case, we have a triangular lot. So meron siyang legs na 18 meters and 24 meters. And if a building, for instance, is to be risen in this land, the longer side of the building coincides with the hypotenuse of the triangle. So we have our constraints, and we have to find the dimensions of the base of the building for maximum floor area. So dimensions of the building, which is in this illustration is shaded in red. We have to maximize the floor area given that the constraint should be maximized in the triangular lot. So we have to assign variables. So clearly the formula that we must come up with is the floor area of the base of the building. So the floor area must be maximum. So we have to look for the area of the triangle. Of the rectangle using the dimensions assigned as x be the length of the rectangular base and y would be the width. So required na may bala na to kung unsa ang dimensions ana nga building. So as stated just a while ago, mo ni siya ang atong primary equation because the area concerning x times y, or the dimensions of the building, is the parameter that should be maximized. So nana siya sa ato ang general steps in looking for the general steps in approaching optimization problem. So that's one. So clearly we cannot use the primary equation alone. So we need to provide secondary equation or secondary equations in order to limit the number of variables in the equation to be maximized. So we have constraints with the triangular lot. The legs are 18 and 20 meters, and these are what mainly limits the floor area of the building. So we have to come up with another formula which relates the base of the building. So formula rather that relates the 18 meter and 24 meters na kanang dimensions. So in this sort of problem, we can come up with two secondary equations, and the only way to do that is by using ratio and proportions of similar triangles. So mo na siyang advantage when we are dealing with right triangles. So there are many instances like that in geometry. You just need to be more creative and of course be familiar with the prior knowledge about shapes, areas, and dimensions. So Ang unang nga triangle na pwede na to gamitan ni 18 and 24 meters is kaning triangle na shaded in green. So this is the ratio and proportion of similar triangles na applicable sa green na triangle. Ako lang drawingan ani. So muna siya. Tapos mani siya atong dimension A and B. So para ma-find out na siya na natay 24/18 is equal to B over A. So muna siya ang ato ang 24/18 is equal to B over A. So muna siya ang ratio and proportion sa similar triangles. Now that we have the proportion, mabalik ta dito sa formula sa triangles with hypotenuse para makabalik ta dito sa variable x nato. So x here remains to be the length of the triangle, length of the rectangular based building. So man siya, if we have dimensions a and b, then makita nato si x by Pythagorean theorem. So man siya using Pythagorean theorem. So just extract that triangle out of the diagram. So man siya atong formula na gamiton. Then i-substitute naton siya dare. Then a bit of a simplification, then we have another secondary equation relating x. So x in terms of b, but it doesn't end there. Kailangan gyapon tag variable y na i-substitute na to in terms of b. So using another similar triangle na magamit nato dare is kaning area naman tay y, mura na siya tong pwede gamiton kasi. In fact, pwede po natin siya gamiton, pero it is a particular example, we will use the triangle shaded in blue. So extract na to ang iyang hypotenuse, which is along the base 24, so 24 minus b. Clearly ang length ani niya is 24 minus b. Tapos ang length ang niya ay ang hypotenuse rather is 24 minus b, tapos one leg along the building is katong y nga dimension. So we have 30/18 is equal to 24 minus b over y. So that's another application of the similar triangles. So nanatay y in terms of b. So muna na siya tong gamiton karon to substitute back to the primary equation a is equal to x times y. So muna siya ang gibalik dare. So nanatay a primary equation in terms of only one variable, so that way we can do the derivative, the first derivative. Then of course the important step is to set the derivative equation to 0. So mahibalan na to ang value sa b. Okay, in terms of b man siya, luckily for us wala tay kana bitong kanang multiple values of b, kay kanang first degree naman ang ato ang derivative equation. So using tong mga secondary equations na to, we can substitute the value of b to look for the values of x and y. So upon simplification, naatay x is equal to 15 meters. So dapat 15 meters din ni siya. Then ang atong y is equal to 7.2 meters. So kana siya is 7.2 meters. Mo na siya ang max, ang dimension sa building which will create the largest area para sa ato ang building. Then ang atong fifth na problem is find the point of the graph of y is equal to x squared in the first quadrant that is closest to the point 0, 3 and find the minimum distance. So closest distance gani, so meaning minimum distance. And from your previous knowledge in algebra, gitudluan man mo unsay mga basic na kanabitang graph sa mga equations. So clearly y is equal to x squared is a parabolic equation with vertices along the origin point of origin 0, 0, kaya wala man tay mga additional numbers na makita dara. That's the simplest that it can get. And the problem wants us to find the point on the graph that is closest to the coordinates 0, 3. So kanang 0, 3 class, that is along our parabola. Muna siya ang ato ang point di ay nga outside of the parabola, and we need to find the closest distance at the closest point within the parabola to that of point 0, 3, and we also need to look for the minimum distance. So since we're dealing with a Cartesian coordinate plane, so let manadali lang magkanabitang mag let x let y kay mo naman na siya mismo ang coordinates. So let x be the x coordinate for the point of the parabola closest to 0, 3, and y as the y coordinate to the point on the parabola closest to 0, 3. So this type of problem class can be easily analyzed, or mas mapadali itong analysis if we sketch the problem. So you better do that. So mani siya ang iyang sketch. Then using kanabitang distance between 2 points na formula, na siya ang ato ang main formula na kuhaon kay dapat man daw closest na distance. So clearly we need to use a distance formula. Tapos kading distance formula class is also given sa calculus. So considering we have 2 points, ang formula sa distance is square root of x2 minus x1 squared plus y2 minus y1 squared. So man na siya itong nakita dere. Tapos i-substitute na to ang mga given point, which is 0, 3. So you have x minus 0 and y minus 3. So nabili na lang sa equation, d is equal to square root of x squared plus y minus 3 parenthesis squared. So since our primary equation is in terms of two variables, we need to look for a secondary equation. So no-brainer kay naman ang equation given ni parabola, which is y is equal to x squared. So i-substitute na to x squared diya sa x squared nga nasa primary equation. So therefore mahimo na siyang square root of y plus parenthesis y minus 3 squared. So mana ni siya ang ato ang primary equation in terms of only one variable. So mana na siya atong i-derive, which is what happened here. Tapos simplified further here. Then important na step is to to equate the first derivative equation with 0 or to 0. So with that, mabala na nato ang value sa y. It's just a matter of simplification na lang. And since we have the value of y, we can substitute that to the secondary equation, which is y is equal to x squared. So we will obtain positive negative values of x, which is square root of 5 over 2, or square root of 2.5. So we have possible points nga kuan answer sa x. It could be square root of 5 over 2 away to the right of the y-axis or to the left of the y-axis. So we need to go back to the problem class. The point must be on the first quadrant man. So clearly, that would prompt us na ang atong value sa x is dapat positive. So we will pick this one. Kana positive square root of 5 over 2. Then we go back to the distance formula para may balaan ang second part sa katong gipapangita sa to, which is a minimum distance, which is at square root of 11 over 2. So muna siya ang final answer nato. Then let's go to the related rates na problems. So this is interesting class because this is like kanang bitong ordinary kind of situation with kanang kuan di ay, which can be explained through the tools available for calculus. So the problem states that a man 6 feet tall, so 6-footer ang tao, is walking towards a building at a rate of 4 feet per second. So dagko kay siya glakang no, 4 feet per second, imagine. If there is a light on the ground 40 feet from the building, so assuming na kana bitong gabi ini siya nga setup kay nagpaandar ra matag suga, otherwise wa jud pulos ng suga. How fast is the man's shadow on the building growing shorter when the man is 30 feet from the building? So, I want you to imagine class na samtang ano bitaw ta, ang sa tawagan, nagkalayo ta sa light source, ang atong shadow na maka sa wall is nagagamay pod, or alternatively, samtang nakaduol ta sa wall, mas nakagamay to shadow, mas naga-approach closer to our true size or true kanang bitaw height, ang height sa atong shadow. So mo na siya ang gina-imply ani nga problem is ang rate of how the rate of the shrinkage sa length sa shadow which is casted on the building. So for illustration mo ni siya, this is exactly what the problem is talking about. Natay 6-footer nga tao, then natay wall, natay 6-footer nga tao, then ang light source, light on the ground is 40 feet away from the wall. So we have to find for the shrinkage. Maga-shrink mo na siya. Mo na siya itong pangitaon when the man is 30 feet away from the wall. So mo na siya itong mga variables involved. So we have x and y. Ang x is ang distance traveled by naman from the light source on the ground. Then ang atong y is height of the man's shadow on the building. So makita nila nato dahil sa illustration class na kanang y magkaanam-anam nagka-shrink, samtang x nagkaanam og kataas. Tapos we need to take advantage of variable x because naatay given na kanabitang speed of walking sa tao which is 4 feet per second, so that can be expressed as dx over dt. So muna siya ang ato ang kanabitang at pangitaan o counterpart sa dy over dt. So muna siyang required rate of shrinking shadow of the man in the building when the man is 30 feet away from the building, so at a specified point in time. So natay based on the illustration natay ma-obtain na kanabitang similar triangles. So kanang similar triangles mo na siya ato ang na x and 6 dimensions and 6 nga dimension, the legs dahil sa triangle x and 6. Tapos napo tayo triangle na ang dimension niya is 40 and y which is naa dari sa kilid. And mahibala na ma-relate na to ang equation using similar similar triangle, so by ratio and proportion. So x times y is equal to 240. Then i-derive na nato na siya using kanabitang implicit differentiation. So unlike sa optimization problem class where we have we need the primary equation or optimization equation to be expressed in only one variable, dari class sa related rates, we do not need to do that because kung man ni siya kanang implicit differentiation man ang mas ginagamit nato dari. So nanatay x dy dt plus y dx dt is equal to 0. So man na siya tong related rate equation. So when the man is 30 feet from the building, meaning he is 10 feet away from the light source. So mo nang natay when x is equal to 10 feet. So para mahibalaan dyan na to ang dy over dt, we need to find the variable y first. So nanamatay x, nanamatay dx dt. So kani siya nga rest of the equation would be to solve for y, which is balik ta dito sa similar triangles. This is equal to 24 feet. Tapos finally ma-substitute na nato siya as of this point. So mao ni siya. So atong dy dt is equal to negative 9.6 feet per second. So mao na siya ang rate sa shrinkage sa shadow. And it is important, class, that we state them in negative because shrinkage man, so nakagamay nga quantity. Then ang fifth na example is a balloon is released from the ground 100 meters from an observer. So siguro na ipa-party. Then the balloon rises directly upward at the rate of 4 meters per second. So this is a rough assumption lang kaya ang balloon di mo dyan na directly upward or perfectly upward na motion. But anyways, the observer or kanang taong nagtanaw sa balloon as it rises up is located 100 feet from where the balloon is released. So mo na ilang distance, mo na ilang kalayon sa initial nga state. How fast is the balloon receding from the observer 10 seconds later? So unsa daw kapaspas ang unsa na ang distance sa balloon, ang pagtaas sa distance sa balloon o sa observer, sa balloon itself, class, 10 seconds after it was released. So natay illustration to relate that. So a lot of our problems so far involves kana bitong triangle. So ang nakanindot ang triangle mga glass is pwede siya ma-ratio and proportion easily, just like sa number 4. But in this case, we are only concerned sa kanabitang y na base and sa hypotenuse, which is in this case ang diagonal distance s. So we have s, y, we have dy dt. So ang ato ang duha ka equation is s, duha ka variables is s and y. Steady lang man ang x because it remains 100 meters man daw. So with that, napunta dapat ds over dt tapos dy over dt. So naman tayo dy over dt or the rate at which the balloon rises up, which is 4 meters per second. So ang itong pangitaan is ds over dt. So natay primary equation which we can reconcile back sa kanabitang Pythagorean theorem. So natay 100x squared, so tala ko x squared plus y squared is equal to s squared. So kanang 100 mo na siya ang x. So natay x squared is equal to 100 squared plus y squared. So by implicit differentiation, natay 2s ds over dt is equal to 2y dy over dt, in which ang 2 is makancel kaya naman siya present both sides of the equation. So natay related rate problem na equation nga s ds over dt is equal to y times dy over dt. So natay variable y, napatay variable dy over dt. Unsa pa yung mga wala nato? Ang una nato di ay is dy over dt, pero kanang wala patay y nga equation mo din dapat atong pangitaon after this. So ang atong problem now is how do we look for the value of y. Diha na mosulod ang speed na equation. Speed is equal to distance over time. Naman tay time which is 10 seconds. Naputay speed which is 4 meters per second. So masolve na to a distance sa y. So after 10 seconds may balik na to kung asa nga na altitude si balloon. So a little bit of kanang solving it. Basically we have y is equal to 40 meters. Tapos kanang s is also unknown. So daghan kitag problema ani nga problem class. Naga-STEM lang na problem ba? Pwede man ta nga mo balik ta dito sa Pythagorean theorem na equation. So substitute y kung substitute nato si y dira, which is kani, may bala na to si s, then we would simply go directly into substituting it dito sa tong equation. So ato ang ds over dt is equal to 8 square root of 29 over 29 or 1.486 meter per second. So therefore the balloon recedes or goes away from the observer at a rate of 1.486 meters per second. So mao na siya ang rate at which nagkataas ni siya nga distance. So that's it for the recorded lecture class. Thank you so much.